I'm going to cover the installation of the Victron BMV 712 as well as a battery disconnect, a true battery disconnect for the house batteries, and the reasons for doing so. If we hop on over to the Silverleaf panel, we'll see here that I have a reading of 70 degrees, 13.7 volts, 19 amps, and the inverter is in a float state for the charger. And what's really important to realize that's happening here is that this data is from the point of view of the inverter. So it's not terribly accurate. A couple of things. First, the voltage readout here is the voltage that the Xantrex is putting out at its terminals. It is not the voltage that the battery is seeing due to line losses. We'll see in the video when we look at the Victron, as well as what I have observed directly with a voltmeter, is that the batteries are seeing a voltage of approximately 13.6. You'll also perhaps wonder why these numbers are higher than what you're seeing, and this is because I have set up a custom profile for my batteries based on the technical specifications from the manufacturer, because the generic profile isn't quite right. So if we take a look at this screen here, you'll see that I've gone into a custom setting mode here, which you can't access without a special password. If you go to advanced, you get prompted for a password. Silverleaf has asked me not to publish that information, so if you want to do this yourself, my recommendation would be to call Silverleaf themselves, tell them that you want to set your battery profile to match the specifications of the manufacturer, etc., and hopefully they'll give you the password. They didn't seem to have any trouble giving me the password, so they're just trying to prevent people from screwing up their own systems. So anyway, what you see here is a bulk voltage of setting of 14.4, which I think is the same as the generic profile. The absorption is down to 14.2. I believe that was 14.4 in the generic profile, and the float voltage I've up to 13.6. I forget what that was. It might have been 13.4 or 13.5. So those are the settings that I made there. The other changes that I made were with respect to the battery capacity. It was set at 800. It's actually 816, so I just set this to 820. That was the next available setting, and I increased the absorption time. The max absorption time for the Discover EVGC6A batteries is 5 hours, and so I set it to 4. Only because sometimes if you do things like switch from shore powered generator or some other event like that, the system goes back into absorption mode, and you can technically exceed the maximum absorption time by doing so. So I just reduced this to 4 hours just to play it on the safe side a little bit. So let's get into the reasons for adding the BMV 712 and the cutoff switch. So we'll categorize them in a few different ways. We've got accuracy, we've got alarms and triggers, we have the ability to do sort of a capacity test, and the cutoff switch is essentially what it is. It's a cutoff switch because what's provided at the front door doesn't cut off all the loads. So let's get into that. The accuracy piece, which I mentioned a little bit earlier, what you're seeing at the Silverleaf panel is what the Xantrex is reporting, and that means that you're getting only a partial view of what's going on. Yes, typically speaking, the Xantrex is drawing the biggest loads in the system if you're boondocking, but there are plenty of other 12-volt loads. Even the lights, the ceiling lights, for example, in the living room, if you turn all 12 of them, I think there are on in here, you're drawing at least 60 watts. That's 5 amps at 12 volts. So that's just the lights, right? And so it's really important to have a system that can look at what's going on in your battery bank from the point of view of the battery bank and count everything that's going on. If you're not doing that, you're running a little bit blind, and you're basically playing a guessing game with respect to the battery voltages and state of charge. If you have relatively low load on your system, then you can look at the battery voltage as reported by the Silverleaf and guess. You know, if you're reading 12.3 volts, I think it's 50% state of charge, you can guess you're at about 50%. You could easily be off by 10% or more, depending on the load, and especially because there are line losses between the battery bank and the inverter. You know, for example, I have like I mentioned earlier, I have the inverter set to a higher voltage, and so you see 13.7 volts in the silver leaf panel, but there's only a reading of 13.6 of the batteries, right? So that 0.1 volt difference can actually make a pretty big difference with respect to knowing your state of charge. And then the things get all sorts of inaccurate, when you have when your system is under high load. Just turning on my toaster oven draws 1,500 watts of AC power, also 1,500 watts of DC power, which translates into hundreds of amps of load. And when you do that, your readouts become extraordinarily inaccurate. And if you have a high load for 10 minutes, your silverleaf panel is going to start showing you battery warnings, and you're going to see numbers that are going to start to freak you out, like, oh my gosh, my battery is low, or there's a problem with the battery. And that's really not the case. It's simply because it's being measured at the point of view of the Xantrex and not the battery bank. So long-winded version of accuracy is important. So the way that happens, and you'll see physically the shunt involved, is to essentially run all of your negative current through a shunt. And by doing so, you have one point where all of your energy or your power through the battery bank is going. And if you do that, then there's a way to measure it and get an accurate reading. So it's actually watching the current over time, and as a result, it can give you an exact number of amp hours, right? And we know that the capacity of the battery bank is, in this case, it's technically 816 amp hours. And so if you draw 408 amp hours out of the battery bank, which the shunt can measure, then you know you're at exactly 50%. And of course, the battery monitor panel will show you 50% state of charge, and you can feel confident about that number. Second thing that the BMV will give you is a set of alarms and triggers. And that's one of the reasons I pulled the BMV into the coach instead of leaving it in the battery bank. Because if the batteries get below, I have it set to 40% state of charge, I want to be woken up in the middle of the night and told about that. I wouldn't be able to hear that alarm if that device were down in the basement. So that's reason number one. Reason number two, with respect to alarms, is that those same alarms can set off relays. Now, I'm not making use of this feature. You could if you wanted to. Maybe I will someday. If the state of charge goes below some threshold, let's say 50, 40% or whatever you want to set, you can have it do something like cut off your battery bank, and you can set your system up to go into sort of like an auto self-protect mode. So really great feature there if you set that up. I haven't bothered to do that. I don't think I'll be in a situation where I need to worry about that. And that is because of the cutoff switch, which I'll talk about in a second. And finally, the last reason for the BMV is I can perform essentially a capacity test on the bank of sorts. I am not going to be able to individually measure any one of the 8 batteries to make sure that one of them hasn't gone bad. But the reason I wanted to do this was because of the accident that I was in, which caused the Newmar, or Destiny as she's called, to go into the body shop. The body shop, even if they did press the disconnect switch, I have no idea or not, the one that's provided with the Newmar, that disconnect switch doesn't actually disconnect all the 12-volt loads. You still have several amps worth of load on the system, and inside of I think it's a week, you will drain the battery bank. It was at the body shop for several weeks, and so when it was returned back to the dealership 3 weeks later or so, the tech there measured a voltage of 0.7 volts at the battery bank. And so naturally I was worried about the long-term effects and the damage to the battery bank. And what I was able to do with this was to say, all right, let's take a look at the discover.com, I think it's Discover Battery, whatever it is, for these batteries, the manufacturer. And I could see that state of charge, 50% state of charge is 12.3 volts. And so now that I have the ability to monitor the current power really going through the system, I could set up a test where I relatively slowly, so under around the 20 amp hour rate, I would draw 408 amp hours out of the system and then take a look at the voltage at that point. And sure enough, the voltage was right around 12.3. So that gave me a good sense that the batteries were still in healthy condition. I could still draw what I'm supposed to be able to draw out of it. And the other quick test I did too is I put as much load on the battery bank as I could to make sure that they wouldn't fail under heavy load, and I had no problems there. So felt good about that. And then finally, last but not least, for sure, is the cutoff switch. And that really boils down to one reason. And that I kind of mentioned already, that cutoff switch at the front door cuts off most of the DC loads. It does not cut them all off. So you're still in danger of running the battery down after a week or so. And I ran into that situation with the body shop, so I wanted to be in a position where I could leave the coach somewhere and actually cut the batteries off and not have to worry about it. And now that I'm full-time, I think that kind of situation could easily arise. Cross my fingers I don't get into another accident and have to put this thing into a body shop. But I could certainly end up flying home for the holidays or what have you. And I want to be able to put the coach into storage for a week or even just a few days and just flip that switch and know that my battery bank is going to be okay when I get back. I'm not going to cause long-term damage. I'm not going to have any problems getting the coach up and running and that sort of thing. So without further ado, let's get into the nitty-gritty stuff. Really ignore the plethora of wires you're about to see here. My extremely professional installation skills at work. I have not permanently mounted this yet. I've got the cable actually running behind the panel here. You can see the cable actually sticking out on the floor here. This cable runs down into the battery compartment, and I'll show you how I routed that in a minute. But here's the BMV 712, and what I currently have it showing is the state of charge, and you can see a number of different things. You can configure a number of different things in here. So you got your state of charge, you have your temperature. If you were looking closely at the silverleaf panel, it also said 70. There's a separate temperature probe for this unit as there is a probe for the Xantrex. The current battery voltage, you'll remember that you saw 13.7 on the silverleaf panel. This is reading 13.6. Like I said before, right, the current draw in the battery is basically 0 because it's fully charged and floating. We get a watt version of that same information. The amp hours consumed. Here's the display portion of the BMV 712. The way that this works is this wire connects to a shunt, and that shunt needs to be wired into your battery pack. So let's go take a look at what that is all about. The blue wires are new. They're mine. I have not put them into wiring loom yet to protect them, and I definitely need to. In fact, I've put about 2,000 miles on the coach since I did this, and you can see that these wires are already rather dirty with essentially road grime. So let's take a look at what we've got here. This is how the Xantrex knows what the temperature reading is, and this is how the BMV, the Victron BMV, knows what the temperature is. That goes to the back side there, the positive, and there's a temperature sensor, and this is also the power lead going to the shunt that I just mentioned. So in order for this shunt to properly do its job, all of the negative side of the battery must be routed through the shunt here. So I have one 4-aught cable going to the closer center of the negative side of the battery pack into one side of the shunt, the input side of the shunt. The output side of the shunt, for various reasons, didn't have the wiring and whatever. Anyway, so I ended up with two 2-aught wires here. This really should just be a single 4-aught wire, but this gets the job done. And I decided to use a bus bar. This is a 600 amp bus bar I got on Amazon. Actually, I have 2 of these. There's one for the negative side and one for the positive side. We'll see in a minute. And it just made the wiring situation easier. And what I did was I connected the 3 negative cables that were connected directly to the battery pack to the bus bar, and I tried to prioritize the wires so that the highest load, such as the inverter, was the closest one to the input side. So it's easier than stacking the wires. It really wasn't possible to stack those 3 black wires directly to the shunt. I tried, the bolt doesn't fit. I probably could have gotten a longer bolt, but I just didn't really like the way that ended up creating. It was just ended up with a poor wiring organization. Things were in the way, and the battery couldn't slide in and out of the tray particularly well. Things just didn't work really well. So this ends up giving me a really good clean setup. I only have one wire that needs to move around when the tray slides in. You know, at least one load carrying wire. Of course, the wires for the temperature sensor and whatnot have to move too. And then there's one wire, again, for the same reason I used the bus. There's one wire for positive. So here's that telephone cable you saw inside, connected to the BMV 712. I do have that protected in wiring them, because that goes up and out of the battery compartment, and it goes across. Let's show you what I did here. That's going to be actually quite difficult to do because I have the jacks down. So, you know, you're not going to be able to really get it here, but what I did was I routed the wiring loom up and, you know, behind the wheel well here, you know, and continued this direction, and it ends up coming through here. So I drilled this hole, put a grommet in, and used some sealant. The wiring loom stops on the other side of this panel here, so it's fully protected right up to this point. And then the wire comes up here. It goes up into this pre-existing hole. There's plenty of room in here, so I just ran the wire right up here, and that goes right up into the driver's side compartment right behind that panel that I showed you earlier. So that wasn't too terrible to route the wire. I just have to decide where I'm going to mount the BMV 712. So that's how the shunt is done. We'll take a look at the battery disconnect here. So I've got the positive side on being disconnected, and what I've done is I've run a 4-aught wire from the sort of the far center. I tried to have, you know, ideally you'd be pulling from the center of the battery pack on both sides, but since there's 4 batteries, that's not possible to do. So I do it on the close side here, and I do it on the far side of the center here, and I run the positive into the battery disconnect here. Battery disconnect then goes up and around to a similar, actually the same 600 amp bus bar that we see there. So we've got another one of those up here. The difference is it has a cover on it for protection, so we don't, you know, cause any major shorting or fires or anything like that. You can see 2 wires that are encased in black wiring loom. There's a third one that you can't really see. Those are the 3 that were connected by Newmar to the system. Again, I tried to prioritize the highest amperage to be closest to the input, just for efficiency purposes. And that's it. I didn't change the wiring in any other fashion, so the fuses are still there and that sort of thing. So when I did this work, I had to pull the tray out, and I pulled all the batteries out in order to be able to get back far enough and do a good job drilling the holes and putting the screws in for the bus bar, both there and on the right hand side here. And so that required me to disconnect, you know, all the cables that were there, which I had to do anyway to move them to the bus bar. I also had to remove these bus bars, and I had to remove the battery grease on all the terminals, cleaned everything up, put it back together, and reapplied some grease there to protect it from corrosion. So all in all, this effort was quite a bit of effort, you know, locating all the right spots to mount everything and whatnot. I wanted to add that I chose to put the shunt here because it's kind of up to the left here. It's not going to receive a lot of road debris. I did have it there briefly, and for the brief period of time it was there, it did receive some road debris right on the top here, and that just wasn't going to end up in a good long-term situation. So the advantage also of moving it here is that there's actually 2 pieces of metal here for this to screw into, so this gives it a really good solid feel here. It wasn't as solid there, but that's okay for the bus bars because the bus bar has a much wider mounting plate and 4 screws holding it in, so those are held in pretty well. So I ended up being pretty happy with the location of everything. That was, it gave me a good setup for the length of wires without having to trim and redo the original wires, so I could just leave all the connectors on there. I sure as heck didn't want to have to go and recrimp a bunch of connectors and whatnot everywhere. So the only thing that you might choose to do differently is to, instead of mounting this directly to the metal panel here, there is a gap between the metal, the post, the screw post that the positive side goes into, and the metal here. But this is ground, right? And so, if something got in there or whatever, you could certainly short, create a short here, and that's not great. So a piece of wood, plastic, something to act as an insulator between here and here would be best.